Dear students, today we discuss about relations. First, we must know what is a relation. A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. We know that the elements of a Cartesian product A cross B are ordered pairs that we discussed in the previous video. So if R is a relation from A to B, then R is a subset of A cross B. If R is a relation from A to B and A comma B belongs to R, then it is expressed as A R B. Okay? If an element A comma B is not belongs to R, then we express it as A R cut B. So these are the expressions that an element belongs to a relation or not. For example, let A is equal to ABC, B is equal to XY, and R is a relation which contains four elements A comma X, B comma Y, C comma X, C comma Y. Now A comma X belongs to R, so we can write A R X. B comma Y belongs to R, so B R Y. But we see that A comma Y is not in the relation. So we can write A R cut Y. Now any relation from one set to another can be expressed in diagram. That diagrammatic represent of a relation from a set A to another set B is called arrow diagram. A virtual representation of this relation that we defined in the earlier slide R is shown in the following figure. It is called the arrow diagram of the relation. Now to draw an arrow diagram, first we draw the first set, then we draw the second set, and you see that R is equal to AX, BY, CX, CY. So that means there is a relation from A to B. To represent this, we draw an arrow line from A to B. There is an arrow at the end, you see, you must put an arrow. And this relation is R, so we write R. Now A comma X is an element. To represent this, we draw a line from A to X, and there is an arrow also. This represents that the relation is from A to B. Similarly, BY, so B goes to Y, arrow sign. CX, C goes to X, and CY, C goes to Y. So this is the complete arrow diagram of our defined relation from set A to the set B. Now two definitions, domain and range of a relation. If R is a relation from a set A to another set B, then the set of all first components of the ordered pairs of R is known as the domain of R. That is, domain of a relation R from A to B is defined as DOM R A such that A comma B belongs to R. Next again, if R is a relation from a set A to another set B, then the set of all second components of the ordered pairs of R is known as the range of R. That is, range of a relation R from A to B is range R B second component such that A comma B belongs to R. Now relation on a set. If both the sets is same, that means if the relation R grows from a set to itself, If R is a relation from a set A to A itself, then R is called a relation on A. Okay. Now, number of relations. So if you are given a set and another set, and we define relations from the first set to second set, then how many such relations we can define from A to B? There is a formula. If Na is equal to P, what is Na means? Number of elements in the set A. And Nb is equal to Q. That is number of elements in the set B is equal to Q. Then the number of relation from A to B is 2 to the power P into Q. And one example, suppose A is ABC, 3 elements, B 2, 3, 2 elements. What is the number of elements from A to B? Here Na is 3, Nb is 2. I hope you understood. So the number of relations from A to B is 2 to the power 3 into 2, that is 2 to the power 6 is equal to 64. So we stop here today. We meet in the next video.